Welcome to the Breen Machine video blog. This is John Breen. Today we're going to talk about upgrading a SLC150 PLC. Now, I recently put out a video showing the process of installing the new PLC and testing the system, and I've had a few questions about how we selected a PLC, so that's what we're going to talk about today. Here's a picture of the system, or the important parts of the system that we're talking about right now. This is a PLC here. It's a SLC150. It's 30-ish, maybe more years old. And this is expansion I/O for that PLC. They're connected by this ribbon cable here. I also want to show you, we collected at the beginning of the project the drawings for this machine. And I'm not going to go over everything on the drawings. Let's just suffice it to say that the top part is mostly motor control and power. But then this left part here is the PLC. And the part on the right is that expansion I/O we were talking about. So if I zoom in on this, we can see a little bit better what's going on here. At the top of the PLC, we have inputs, and at the bottom we have outputs. And we can count all of these. So when we're getting ready to pick a new piece of hardware for this, a new PLC and perhaps expansion I/O for that PLC, I'll just count inputs here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This is something that got penciled in. And then this one here, I'm not going to count because it's wired to the same input as something else. So 18, and then if I look over here, we've got 3 more, 19, 20, 21 inputs on this system. Now I want to point something out here as we count the outputs. There are a few things wired on the PLC here, or rather on the expansion I/O. You see there are a lot of wires coming out of the bottom here. These aren't all used. These, if I come back to our drawing, you can see that there are a lot of things wired to fuses, and these are just in case, they're just spares. And since this machine is 30 plus years old, I'm guessing we're not ever going to need them. So as we plan an upgrade PLC for this, we don't really need to worry about those. I'll still want to have a couple spare just in case, but I don't need to wire every one of these. These aren't real outputs. So if I want to look at that picture again, I just want to point out another place we can see that same information. These, I happen to know, are all coming up through the wire duct over to these fuses. These are the output fuses that we saw there. And they're all wired on the top, that's coming from the PLC, but they're not all wired to actual devices. So just another thing to pay attention to when we're looking at a panel like this and planning to upgrade it. I also want to point out, if I look closer at the PLC, the things we want to count here on the inputs, it's the things with numbers that are wired. So we've got 1, 101, 2, 102. These are all wired, they're inputs. We're not going to count things that say COM. It looks like they're not actually wired in this case anyway. And then on the outputs, if I zoom in just a little bit here, we also have some things that we don't want to count. For example, this says 111, so we've got the power for output 111, and then there's a relay in here, a switch, that turns on the actual output. So only one of these pins is actually the output, that counts as 1. Same thing goes for this. This is a bank of outputs that all have the same power, and then again, each one of these is a relay switch inside of there. This VAC doesn't count, even though there's a wire there. So 1, 2, 3, 4, 5, 6 is how we would count this. And again, I'm not actually going to count it on this device because I have drawings that I've confirmed are reasonably accurate, and they show that some of these outputs are actually spare. So I will prefer to count those on the drawing. Let's come back over here and let's think about I/O type. In this case, just based on the age of the equipment, I can guess that most of the inputs and outputs are going to be digital and are going to be 120 volts. We have some other clues on here that tell us that. The red wire, according to code, that's got to be high voltage. It's not 24 volts. Is that a guarantee? No, obviously sometimes people don't follow code, but that's a clue. It adds to it, or it adds to our confidence there. We can also measure on the panel. If we're actually on site, we can get out our multimeter and measure. We can look back at the prints again and see what kinds of things are connecting to these lines. And if I follow back let's say the power bias for this here, follow it all the way back here, it's wire number 5. Follow that line up. I would bet you we're gonna find somewhere that's connecting up to 120 volts. So I'm following it all the way up here, and it comes through all of these switches, comes back to L1, which sure sounds like a AC line. And if I look here, it's on a transformer, and I don't see that it's actually saying 120 volts here, but it's taking whatever's coming in here, maybe it's 480, and turning it into something lower power. And it looks like on this side of this transformer, it is labeled 115 volts. So that's nominally the same thing as 120. And that's what I'm gonna keep calling it for the sake of consistency. So again, in this case, we've confirmed a few different ways that this is 120 volts. And I'm just gonna tell you that the inputs also have that number 5 there. Inputs are also all 120 volts. So whatever hardware we choose to replace this has to also be 120 volt capable. And that means on the inputs, it has to actually be rated for 120. That'll usually be, it's only 120. It can't handle 24 volts DC or anything like that. And then the outputs will use relays just like they used. And relays are capable of usually anything. And in this case, we can just confirm that the relays that we choose are actually rated for 120, but that's usually not a problem. So another thing to consider as we're upgrading this PLC, processing power, memory. I'm just gonna tell you, when we're talking about a PLC at this age, you can't possibly buy a PLC that doesn't have enough memory or doesn't have enough processing power to replace what this system was doing. So I'm not even gonna worry about that. We're gonna look at 2 main different styles of PLC, and this is an Allen Bradley system. I generally always stick with the same brand when I'm replacing a PLC because there are usually some convenient tools that help us upgrade the program, and the suppliers tend to be more interested in helping us if we're sticking with the same manufacturer. So often a system this age, we have to get the supplier out to help us pull the program out of it so that we can do the conversion. And it's just good practice to, and I always think it's worthwhile to those people if we, buy more products from the same manufacturer to show our appreciation for that extra help. So within Allen Bradley, I know there are 2 different lines that tend to replace this simple type of system well. One is the Micrologix line, and we would look at maybe the Micrologix 1100 or Micrologix 1400. Those are the Ethernet versions. And I believe these 2 actually have free software support. That version of software is RSLogix 500. And for most PLC support, that software costs money. But for those 2 versions of Micrologix, I believe it can be had for free. And you would have to talk to your supplier to get that. The other line of PLCs that I would consider here is a Micro 800. That's actually what I'm going to be doing here. I'm going to pull up the Micro 800. I just did a quick Google search here. And I'm going to go to the first link that's on Allen Bradley Rockwell's site. And this comes in a few sizes and styles. Generally, the higher number, the more I/O it has. For a given project, you're going to want to poke through these and see which one fits your needs best. I'm just going to tell you that for our purposes, the Micro 830 is the right line. And then we can click on this product selection. I can say, I know that my digital inputs should be 120 volts. That's why we checked that. And I know that my digital outputs should be relay. So it gives me 2 options here. This one has 10 inputs and 6 outputs. I know that's not going to be enough because I counted 21 inputs. This has 28 inputs and 20 outputs. So let's just verify that 20 outputs will be enough. So again, I'll count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 20 will be plenty. So that's my part number right there. Now, if I pull up the documentation for this, it's going to tell me that this PLC can only handle 24 volt DC input to power itself. That's not for the I/O inputs, that's just for power. So this line of PLC actually comes with a little snap-on module that can do the conversion for us. And so it takes 120 in and it gives us 24 out, and then we just have to wire that. It's very simple. And just for reference, this is again what it looked like when we were done doing the upgrade. Notice that we've taken out the PLC and the expansion I/O module, and we've wired up just this new PLC. Since we had to run a lot of new wires to get the right lengths for the right places here, we also pulled out those spare wires just because we didn't want to reconnect them here. And if I zoom in, this right here is the snap-on power module that I was talking about. And again, that'll be right in the manual for this PLC. It will tell you to use that. So that's how we pick the hardware. I hope that helps. If you have questions, let us know. Leave us a comment. If you found this video helpful, subscribe. We're going to be putting out more of these, and my goal is to be helpful for you. So the more you tell me and the more you check back, the better it's going to be for everybody. So thanks again. See you soon.